Hello everyone. In this video, we will discuss program number 6P, that is 01 knapsack problem solution using greedy method. Then greedy method is a well-known technique used to get the optimal solution by using optimization or minimization technique. Then let us discuss this program number 6B using greedy method. Then starts with a main program again with public static void main string args. Declare two local variables as integer n and m, where n will represent number of items or number of objects you want to include into a knapsack, and m will represent the maximum knapsack capacity. Then first you have to read how many number of items you want to consider, that is n is equal to in dot next integer. Next you have to consider what is the maximum capacity of a bag or a knapsack, that is m is equal to in dot next integer. Then next you have to create one object for the knapsack, greedy knapsack object as a gk equal to new greedy knapsack, and pass n and m value as a parameters for a constructor greedy knapsack. And next have to make call to the two functions as gk dot read function and gk dot knapsack function. Then let us see discuss what is definition for gk dot read function. Then gk dot read function, for this constructor you have to initialize all the local variables required to solve your example or use it in your program. The next make call to this read function by using for integer I is equal to 1, I is less than equal to n, I plus plus system dot out dot println weights of item I equal to next dot integer, and read the profit of item 1 at profit of item 1 equal to in dot next integer. Likewise, by using the for loop you have to read the weights and profits associated with the n objects you want to consider in your program. Then next you have to consider make call to this knapsack function. To this knapsack function starts with integer I is equal to 1, float f is equal to 0, float solution is equal to 0, then order items. Then as you all know that to apply the greedy technique, first you have to sort out all the items according to their profit to the weight ratio, then you have to make simply call to another function called as order items. Then here in this order items you have to simply order all the items considered, or all the items input items for this program you have to rearrange according to their profit and weight values by using this another function as order items, that is float ratio new float n plus 1. Then for integer I is equal to 1, I is less than equal to n, I plus plus ratio of I equal to float of profit of I divided by weights of I. Then for integer I is equal to 1, I is less than equal to n, I plus plus profit for integer j is equal to 1, j is less than equal to n minus 1, j plus plus. If ratio is less than equal to ratio j plus 1, then float temp is equal to ratio of j is equal to ratio of j plus 1, ratio of j plus 1 is equal to temp, and you have to simply swap the values of j plus 1 and weights. You can simply swap the weights and profits associated with the j. Then swap is an simply swapping that will exchange the two values as shown in this program as swap, and it will swap the values with using the third variable as the temp variable. Then next, once you order all the items according to their profit to weight ratio, then you have to calculate the optimal solution by using this technique as while weight is greater than or equal to 0 and the I is less than or equal to n. If weights of I is less than or equal to w, then f is equal to 1, else f equal to float of w weights of I, solution plus is equal to profit I into f, w equal to integer weight minus weights of I into f, I is equal to I plus 1. This will generate the optimal solution as system dot out dot println the optimal solution with the total profit is solution. This is how to generate. Then let us execute this program with some sample inputs. That is, enter how many number of items you want to consider for this knapsack. Suppose we want to consider the 4 items, then enter number of items as 4. The next you have to consider what is the knapsack capacity or what is the maximum knapsack capacity. Suppose the maximum knapsack capacity is 15. The next you have to enter what is the weight of item 1. Suppose weight of item 1 is 2. Then profit of item 1 is 10. Next enter weight of the item 2 is 4. Then the profit of item 2 is 10. Again enter weight of the item 3 is 6 and profit of item 3 is 12. Next enter weight of item 4 is 9 and the profit of item 4 is 18. With these input values, it will generate the optimal solution or the total profit as 38.